Today we're going to go over some of the highlights we picked that we thought were our favorites for Mastercam 2022. And with the help of some of my friends from the MLC family, we're going to go ahead and go through those. First, I have Bo out of Houston. He's going to go over automatic region chaining.
Hi everyone, Bo Rohde coming to you from Houston, Texas. And I'm here today to talk about automatic region selection, as well as other enhancements inside of our Mastercam 2022 2D dynamic toolpaths. Let's take a look. The first thing you notice is the chaining dialog has a few new options, including automatic regions, where you can select a region and Mastercam will define your cut region, your avoidance regions, as well as air regions automatically. We also have the other option to convert these features into standard chains, allowing us to edit those chains as needed. Under our avoidance region, we have a new option to add additional clearance to our avoidance region. And if we take a quick look under that in our air regions, you can see we now have a new tab as well for expand regions. So what is all this? Let's explain. I'll start off selecting this green face for my automatic region. And when we preview our chain or create the toolpath, we can see that it handles the definition perfectly with no additional input, adding air regions over the small holes and on the open face. Now let's take a look at this blue area that has a boss to avoid. I'm going to select my automatic regions again, just going to select the blue area. Notice how it selects the whole outside outer edge, as well as around my avoidance, and the area to cut is automatically defined. These interior boss are automatically avoided as well. What if we have avoidance and air region on a single face? Yeah, we can handle that too. I'll just select the orange area in the center, and with one click I've selected not only our machining region, we've selected our avoidance region, and we've selected our air region with just a single click. Another option for my toolpath is the clearance tab, which will allow us to add additional clearance around certain avoidance regions if needed. So I'm going to come in here and I'm going to put 1 millimeter of clearance around my avoidance regions. When I preview my chains, notice we still have that same chaining options with our air region. And when I backplot this with my quick verify on, you can see the additional clearance around the avoidance regions. The new expanded air regions option will help with this green face. The original preview chain is kind of squared off. And if we look at our backplot, due to the fact that we're kind of squaring off the radius of the tool, so it's not violating the outside of this air region, so we leave this little green area right here in the corner. If we go back and click on expand regions and preview my chain, notice that it's giving the end mill more room to what I call roam outside of the cutting area. Now when our tool runs, notice how it's allowing the tool to come into the part a little bit sooner. And you can see now the tool is getting full engagement of all material coming out of the air region into the cut. I really like this one. The last thing that I want to take a look at is the convert. So I'm starting with a single face, but when I select the convert automatic regions button, notice it splits it out into individual chains for each cut, air and avoidance regions. So if I look at this air region, I'm going to go in and select the regions chain. And notice we have our air region chain that we have selected, which means I can individually delete, modify, or add chains as well to the automatic selection. So it's a great combination of one-click simple definition, but with the flexibility to split up the individual chains so you can have full control.
Thank you, Bo. So I got a fairly simple part up here. And we'll go ahead and do a quick 2D dynamic. Now, again, notice we got a new field up here on the chaining options for that. And if we do automatic regions, I can come in here, make sure I'm doing solid chaining. The only option it's going to give me is for face. I'll come click into the little pockets. I'll say OK. And one thing we'll notice, there's no machining regions, no avoidance, no air regions. It's just all underneath the automatic region. I'll play with this real quick. So if I do a preview chains, right there you can see that without that expand region, it's just feeding straight out. If we want to make sure that the tool can roll around the corners, we can hit that expand region, preview chains again. Now we can actually get a little more motion in that tool. Say OK, make sure we're using the right tool. Linking parameters, looks good. I can check out that toolpath, looks pretty good. I'm gonna go back into my geometry real quick. If I hit this convert to automatic regions, we are going to notice that we now have a machining region and we now have air regions. If I needed to modify those, you're going to notice they're also all solid entities, so it doesn't convert it to wireframe or anything like that. It's just going to convert it to edge loops and solid chaining. But if we needed to remove one or add one, we could do that here. Now, I know this is a pretty simple part. That wouldn't take you a whole lot of clicks doing it the old way. But maybe I had 10 of these that I was trying to do all at once. Well, with the automatic regions, I would definitely be able to get a lot less clicks and a lot quicker processing time for me programming. So definitely a cool feature.
Oh, hi, I'm Jason with MLC CAD Systems here in Washington. Did you know that in Mastercam 2022 you can use Opti-rough in the mill and the router versions?
What did you just say?
Yeah, it used to only be available in Mill 3D, but hey, now we can use it.
Huh, go figure.
So some of you that have been used to Opti-rough, which is awesome, right? How many people use Opti-rough on a daily basis? Probably almost all of you, right on. So now in 2022 with Mastercam mill and router, not 3D mill, not 3D router, but you have Opti-rough is now included in those two products. So if you didn't know that already, pretty cool thing, right? So, all right.
Reasons for it. You can make it a lot more stock aware. You can rough out large areas just using one toolpath. You don't have to do multiple 2D dynamics to work your way down. So if you guys are on a Mill 1 license, I would definitely start playing with it. Next up, we're going to have Scott out of Utah. He's going to talk about 3D toolpath linking.
Hi, I'm Scott Lindsay. I'm one of the Mastercam experts based out of the Utah area. Today I want to share the changes that they've made to the 2D lead in, lead out, specifically the ramp profile and the 3D high-speed linking parameters page. In 2022, we now have access to the line length, the arc, radius, and the sweep fields. So if we come into our lead in, lead out, and we put some values on our lead in, lead out here, now you can see that our cutter comp is being applied during our lead in, lead out at the top of the line, and during our cut, it is fully activated with our cutter comp all the way down to the corner. Now in this next example, I want to go over the changes that they've made to the 3D high-speed linking parameters page. The cut parameters keep tool down option has moved over to the new linking parameters page. And the transitions page has completely moved over to the new linking parameters page. Now in this example, I want to highlight a few of the key features as far as how the clearance plane acts in the 2022, the new arc fit radius and what that is, the linear entry and exit, and in the transitions page, applying the leads, what a primary lead is and what a secondary lead is. For this example, let's come up here and let's create us a waterline toolpath. And in our new linking parameters page, we got a 4-inch retract. Our linear entry exit is set to 25 thou, and everything else is turned off. For the most part, it's a pretty clean toolpath. We have some transition moves over here where it's doing a close contour. And once it gets to the open section, we get some transition moves here. And the issue I have with these transition moves is that they're right on the part. That is scrubbing right along my check surface. So if we come into the parameters and we turn on our apply leads, you'll notice that we get these really funky, weird transition moves. Now what's going on is this is our lead, but this is our 25 thou entry exit, and then we're doing our transition and then another entry. So this is our exit and our entry. So let's come into our parameters. Let's zero this out. So now we're coming off the part, doing our transition, and then coming back on the part, which looks fantastic. So now let's switch gears a little bit, and let's come back into our parameters, and let's bounce back over here, and let's switch this to one way. So now what we get is we're doing our entry, and then we're doing a rapid move. And I'm not too crazy about this 90-degree move here because that's hard on my machine. And that's where these secondary leads come into effect. So if we come in here and we turn on our secondary leads and regenerate that toolpath, you'll notice that we get a rapid move and a nice sweep on and then a sweep onto our part. So we're not getting that hard 90-degree move right there at the end. So now if we come out here a little bit and look at our rapid moves, again, we have that hard 90-degree move that's going to be hard on my machine. And that's where we come in here, and this arc fit radius, and I'm going to use the term radius a little loosely here, is going to move that transition out. And so then we get that nice arc on arc move here in our rapid moves.
Thank you, Scott. He went over that well enough. I don't need a demo, right? Nah, just kidding. So I'm just going to do a quick, just a waterline on this part. Going into my 3D toolpaths, expand the gallery, we'll do a waterline. I'm going to reset my parameters on this, so I'm not stealing any parameters from the previous toolpaths. One of my favorite buttons, reset stock values, so I don't have to go and type it individually. I'll select these faces. We'll add some avoidance so my waterline doesn't try to go crazy and machine all the way around that surface. Toolpath control, leave alone. Tool, just do a 1/2 inch. Cut parameters, I'm gonna up my step down just so we don't have a million passes processing. On this linking, this is one that I think is pretty awesome. It does make a lot more sense to me that everything is on one page now. I don't have to go toggle between different parameters in the tree to figure out how to set up all my linking. So let's play around with this. I'm gonna leave that. I'm gonna turn off the secondary leads. So now we get a definite idea of which is gonna be our primary and our secondary lead. We have a nice little button. If I didn't want to use the same lead in, lead out, I can set different options, or if I can just say same lead in, lead out for the entry and exit. Say okay, get a pretty simple little toolpath, resume way in. Whoa. We do notice we get that harsh machine change direction change. So I'll go back into my parameters. We'll add a secondary lead, good with those values. Notice that generate toolpath button. So I can just automatically close this, make my edits, and it automatically updated the toolpath. I didn't have to go hit my regen all dirty, anything like that. So now we got a nice sweeping arc in, vertically and horizontally. We still have that harsh direction change on our retracts. Go inside the parameters once again. I'll do an arc fit radius. I'm good with the 150 radius. Hit OK. Again, it automatically regenerated. And now we have that a little easier tool, machine motion up there.
Hi, this is Brian with MLC CAD Systems. Did you know in Mastercam you can now use your notes for toolpaths? This allows you to change the height, the font, any aspect of them, and your toolpath will automatically update.
You guys like editing notes? Maybe you're doing revisions, maybe nameplates. Before we would have to create letters, and that just comes in as arc splines and lines. Well, now you can just create a note, chain it. If you need to change the name, change the rev number, you can edit that note and automatically updates. So you don't have to delete geometry or reapply it. It makes it way easier. Works on even the engraving toolpath. It works with pockets, so it does a lot of cool stuff. All right, next we have David out of Seattle. He's going to go over Waterline and the blend toolpath with us.
Hi, this is David Ferguson from MLC CAD Systems, and I'm going to be showing you a couple of changes Mastercam 2022 has made regarding our 3D surfacing toolpaths, in this case specifically Waterline. Now, on my screen is a very typical Waterline. I've based it off a solid model, and I'm trying to basically do a nice even percentage of steps down the sides of this model. Now, what can happen sometimes, depending on the model itself, is sometimes bits of my part sort of fall in between those spaces of those steps. So they kind of fall into a negative zone where the toolpath just doesn't really know it's there. So I end up missing those sorts of features. So what Mastercam has done for the new release is in Waterline, they've added a new command on your cut parameters page called critical depths. And there are several options for how you want to treat what it considers critical depths. And basically what this is really talking about are flat surfaces on my part file. So I'm going to show you a couple of options. Now, initially, my first waterline here is just a very traditional waterline. And we can see really clearly on that case that some of my passes are basically sort of straddling a flat surface. I'm going to choose the first option available, which is simply to include flats on the model. My toolpath goes from basically ignoring those flats, if I kind of look where that pass line is there, to including them. So it actually will somewhat redistribute my steps to include flat surfaces on my model. So simply by turning include flats on, I now suddenly have this waterline seeing a lot more of that part. Now, I can do you one a little bit better than that. The next option I want to show you is what they call contact flats only. Now that option will basically turn a fairly standard issue waterline into essentially a very, very intelligent wall finishing pass. So I end up, basically what I would have traditionally done with a contour toolpath and a whole lot of chains. I'm basing this entirely off the model and simply using a waterline essentially as a wall finishing routine. So I can go from a fairly intelligent toolpath, a pretty standard issue waterline, to a very intelligent wall finishing routine simply by selecting a different option. Mastercam 2022 has also made some significant changes to the way your 3D blend toolpath can work. Now, traditionally when you think about a blend, you tend to sort of think about open chains, right? But for this example here on the top of this boss, instead what I'm using is I'm using a closed chain around the outside and a point in the center of my drive surface. And that's something I'm only able to do recently with Mastercam. So my first chain is around the outside. My second chain is just a point located in the center of where I'm trying to drive the tool. And I'm using that as my blend curves. So not just open chains anymore. When I do that, though, I do get these transition moves between passes. It's more of a scallop type of toolpath. Well, one of the new things you can do with blend is you can now set blend to be a one-way spiral path. Again, same chain options I'm using, a closed chain around the outside, a point in the center, except this time I'm choosing to do this as a spiral. And I get a very, very lovely spiral toolpath rather than those sort of transition moves. So if I'm looking for a really nice finish on this surface, a spiral blend, and I love saying that, is going to be one of your go-to options, especially because now I literally can do that entire complex surface with just a chain around the outer boundary and a point in the center. I'm going to show you another thing that you can now do with your blend toolpath, and that is go ahead and use it as a one-way 2D, so almost like a raster or a flow line. Now again, this time I'm basing my drive geometry off a slightly different model, so I've got a big gap here in the center of that boss. That's not our final toolpath, by the way. For my blend lines, I'm using a couple of chains. And again, that's something that, being aware that you can do with blend is good to know. The chains don't necessarily have to be on the drive surfaces or connected to it in any way. They're simply helping me control the direction of my path. Now, doing that, I'm going to go ahead and change this to a one-way method, still about a mil step over, but I'm going to go ahead and do basically a 2D collapse. Now, the only thing I don't like about this, and it's not a bad toolpath, is that I am spending a fair amount of time jumping back and forth between those surfaces. We can see those yellow rapid lines between those two areas. So what I can do to stop that from happening, and again, new for blend, is I now have the ability to optimize my cut order, and that basically sort of keeps it confined by region. So with optimizing my cut order set, I'm now spending time on one of these boss surfaces before I jump over to the next. So new for blend is the ability, again, very easily to use closed chains and points to define a closed surface. The ability to turn that toolpath into a spiral. And of course, now the ability to optimize those cut orders when you're doing something like jumping between different regions to keep the toolpath sort of contained to a region before it moves on.
Awesome, thank you, David. Man, he's got a great voice for radio. He does all of our voiceovers. I guess it's better than having a good face for radio. All right, so we have all of our different samples here, but I'll run through one so we can see how it works. In my Toolpaths, 3D gallery, Waterline. Again, I'm going to reset my default so you guys believe that I'm actually doing it here. My favorite, reset stock value. Select the whole part. Toolpath control, I can say include silhouette boundary. We're going to go outside. I have one tool to choose from. We'll use that 6mm bull nose. Cut parameters. I'm not worried about the step down because we're just going to use this critical depths on this one. And we're using that awesome feature, contacts flats only. So basically like a pretty smart contour-ish toolpath. I'm going to be able to come finish all the walls. I'm going to set a steep shallow because I don't need a machine down to the bottom or into the vise. Set my linking parameters. I'll make sure just a little above the part. 25. I'm going to zero out my keep tool down. That way it's not trying to blend in between all those. It's going to come off the wall, make sure it does a clean retract. And we'll make sure that these values aren't too large. So, hey, that's a pretty cool feature, huh? You don't have to hide it anymore. We don't have to, for you guys that I would see in my class, I would do this, and then it would yell at you. You can now do it. All right, I'll say okay. And what we should see is a toolpath coming around, finishing all the walls at those depths. So definitely a pretty quick way to get around there. I also want to kind of show off the ability to go to a point on that blend because I think that's pretty awesome. I'm just going to create a quick point and we'll do a blend around this pyramid. I have a point. Go into my toolpaths. I'm going to expand 3D gallery and then we're going to blend. I'll reset my values, pick the very top 4 walls and the floor so I can come down to it. Toolpath controls, adding a quick boundary chain. Now the curves that blend in between. Again, I'm going to pick that same boundary chain, switch over to wireframe, point, select the very tip top point. Oh, cut parameters. Ooh, I need to add a better tool. That'd be hard to do to display. So I'm going to select a 3mm ball. And, oh no. You guys know that automatic feature? Automatically converts it for you. And so as in metric, typed in inch value. There we go. A little crazy with the lead in and lead out. we got those blend marks where it's transitioning. So again, we have that awesome feature on the cutting method to go switch over to a spiral. And I think I want to adjust those, my arc radius of 10 is a little large. So we get a pretty good little spiral down there with the blend.
Hi, I'm Michael with MLC CAD Systems in Washington. Did you know that in Mastercam 2022, you can update your content files using the migration wizard?
Did you guys know that? No, so if you have content files that we sent to you for post, maybe your HODs, maybe your Mori, and you just want to leave everything default in 2022 and just drop those in, you can take that content file, go through the migration wizard, update it, and then you'll be able to just drag and drop it right into Mastercam 2022. All right, next up we have me.
Hi, I'm Brian Gleason out of the Phoenix, Arizona office. Now I'm here to talk about the all-new unified multi-axis toolpath, along with enhancements done to the multi-axis Deburr.
Mastercam 2022 introduces a completely new toolpath called the Unified Multi-Axis Finishing. This toolpath gives you the same capabilities of parallel, morph, long curve, and even the flow toolpaths in one single unified dialog. It should make it easier to adjust your cut strategy without creating an entirely new toolpath. I already cut the right side of the helmet using traditional parallel with a constant step over all the way down across the face, a morph with a little tighter step overs where the two features morph together, and a long curve with a constant step over as it steps across and goes around the outside of the helmet. Let's program the other side using the unified toolpath and see how they compare. I'll create a new unified toolpath, and the interface looks pretty similar. The cut pattern page is going to look pretty new. In the upper portion, we have to pick what kind of pattern we want. I'm going to go with automatic on this first one, and this is going to create kind of a equal scallop looking toolpath. We have other options. We can do parallel, center morph, and so it's going to look at the surface and determine how to create the toolpath from geometry selected. I'll use the same 25,000 step over. On tool axis control, we're doing surface with tilt, ortho. On collision control, I'll tell it to avoid everything but the face we're finishing. We're going to get kind of a equal scallop toolpath working its way out. Previously, if I wanted to change from a geodesic to a parallel, I'd have to create a whole new toolpath, but just want to change the cut pattern. I'll go to the cut parameters, clear this one out, and I'll do a curve style toolpath. I want it to be treated as a parallel style. That's the only thing I'm changing, and now we have a parallel toolpath almost identical to the traditional one, maybe even better. Maybe I don't want to use parallel toolpath. Let's do a morph. So I'll clear this one out. Add the same curve and a second curve along the bottom, and we'll do a morph between the two. The results pretty much look the same as the traditional morph. Now let's look at the long curve. Modify the unified multi-axis, clear out these, add a curve, and treat it as perpendicular. We see it step along just like the along curve toolpath. But wait, there's more. I'll copy the unified toolpath, and I've got a nice little engraving. Clear out the pattern, add a curve, select the wireframe letters, and start over here. And we'll project this geometry with a max project of 1/2 inch. And we've got our engraving toolpath ready to go. Let's look at some enhancements of the Deburr toolpath. Previously, it used a spherical end mill, and it would break the edge, creating basically two small edges and a concave in between. But if you needed to meet a spec with a radius or a chamfer, this is not going to get the job done. So Deburr toolpath now has the option for a chamfer or a radius. I want to chamfer this edge along the ear. Constant width, 50 thousandths, number of cuts, we can set to 5. And now we get a chamfer edge with multi-passes, and that's going to be a much better result. Let's do this again with a radius edge, and we'll do 50 thousandths rounded. We'll do 5 axis simultaneous, and we'll verify these to see what the edges look like. We have a nice chamfer on the ear and a radius edge on the center rib using multi-passes with the same spherical end mill. I think that's good. No, those Deburr options are pretty awesome. I don't know if anybody had to meet spec and was having to draw on radii on all the sharp edges. Well, now you got a pretty easy way to do it without a whole lot of modeling. Anyhow, let's look at this unified toolpath. Got a fairly simple part. Get in here, I'll use 1/4 inch. Make sure my stock's clear. Cut pattern. I'm gonna come in here and select these colored faces. Here's another new feature. I can preview this. I didn't even pick a cut pattern or anything yet. And I can already see what kind of cut pattern is gonna come without even picking a pattern. It just gave me a nice kind of a raster style. I'm gonna do some of the setup if you ever went through any of my classes. You know, it's cut pattern, tool axis control, collision control. So I'm gonna do fixed angle to Z. Collision control, I'm just worried about the holder. I'm gonna say tilt. We'll add some geometry, go to right view, do a N plus. So that should have selected pretty much everything. Go back up to our cut pattern and start playing with that. Maybe we'll try just let's set this up. We'll do just an automatic. Make sure everything else is set correctly. Awesome. I can preview that. And what we should get is like an equal scallop style toolpath starting from the outside, working its way in. Maybe I want to do something a little different. Maybe I want to do a parallel spiral out. So I can just change this to center parallel, preview that. And now we get a pretty good looking toolpath starting from the middle, working its way out. So now it's going to actually process. So we were able to preview all the toolpath before we actually had to process it. So that's definitely a bonus. And if you ever took my class, it was test this, test that. Now we can test all of that without even generating the toolpath. If we looked at this and ran through backplot, it would start in the middle like we want. But on the ends, I'd end up with a lot of jagged edges. There's options for that too. Using the automatic, I can now go to my containment and I can add an additional cut if we want to preview that. So what that's going to end up doing is creating a pass around basically the containment. So wherever our model geometry is, it's looking at the outside of that and it's going to add an extra pass, almost like a pencil trace, but not quite. Let that generate. If I backplot that, you're going to see one kind of weird option. Probably going to be a problem. If that was all roughed out, I would be basically cutting a trench around the outside first. Another fun button. You have to kind of dig deep for this one, but in the roughing, I can reverse my passes, reach in that. So now I'll start doing my equal scallop toolpath from the inside out and then come back around. Starting from the inside. And now, come on. So now we're going to do the little trace around the outside. So definitely some awesome options in there. Plus, if I needed to change that pattern, I can do it on the fly. I don't have to go reset my model geometry or my tool axis control or any of my collisions. Cool. Next, I want to kind of highlight something that maybe people aren't utilizing on the Deburr. Pretty simple part, right? We got a hole on top, and we have cross hole going through there. You have to deburr that edge. And my guy in Deburr, he's getting a little heavy with the router burr and then the Deburr tool, so went a little heavy on that. Inside the multi-axis, we can do Deburr, and we'll select our lollipop cut pattern. I like to make sure it knows about the whole model. And then I'm going to define my own edge. We go to the tool axis control, and we have all the options for 3-axis, 4+1, 4-axis, 5-axis, and 3+2. I can force this out. So maybe my machine doesn't have a rotary to be able to tilt and get around in there. I can still do it on a 3-axis machine and deburr that edge. Give that a quick look. So we can see that that ball comes in there nicely. I didn't have to do a whole lot of offset contours or anything like that to try to break that edge. So I know we highlighted all those radius edges. I mean, if I wanted to, I could still add that in there as well, but definitely cool options in there.
Marcus has a video put together on mesh modeling for those of you who have to deal with that kind of stuff. Take it away.
Hello, I'm Marcus in Stillwater, Oklahoma, and Mastercam 2022 introduces several new mesh modeling capabilities. But if you're anything like me, you probably haven't ever worked much with mesh models, like STL files. So you're probably wondering, why do I want to be able to do that? Well, let's start with a few basics. Most 3D file types, like step or parasolid, represent geometry through geometric formulas. So a cylinder is actually a perfectly round cylinder in the file, and it works exactly like you expect most 3D models to work. Now, mesh model is made up of a bunch of triangles, so a mesh cylinder is only as round as the mesh is dense, and it technically contains a bunch of flat edges. Now, as mesh density increases, accuracy increases, but so does the file size and the time to process. So if you go too far in either direction, you're going to have potential problems. Now, you may not realize this, but you already work with mesh bodies on a regular basis. Graphics cards, for example, use mesh geometry to display the model on the screen. And Mastercam uses mesh models for some internal features too, like stock models or a bounding box. But those meshes are mostly for display or for reference, and they're derived directly from normal geometry. So if you've ever been sent a mesh model file, like an STL file, you know those usually come all in a mess. And you could already open it up in Mastercam and look at it and maybe create one or two toolpaths, but that was about it. These new enhancements give you the ability to actually do something with that mesh body. And now you're probably thinking, okay, why would I want to work with mesh geometry? Who's using it? And for that, it helps to understand where mesh models generally come from. Places like 3D scanners, where scan points are used to create the mesh geometry, and only the faces that get scanned are converted into a mesh, which means the mesh might be of variable density. The part will often have errors or small holes where the scanner didn't quite reach. So now we have things like the fill hole command, which is great for small holes that didn't get picked up by the scanner. Just select the mesh, highlight the holes, and Mastercam adds a patch. You can also modify the mesh directly. For example, this hole. I'll choose Modify Mesh and select the facets around the hole with this brush tool. If you want to grab it with a brush, left click to select the facets, right click to deselect until you have the exact area you want to modify. The repair fills in the area, but it doesn't exactly follow the curvature very well. So let's use another tool, Smooth Area. This allows us to select the facets in that patch and match the surrounding curvature. This would be a great way to smooth up a patch or fill in an area where there might have been a fixture used to hold the part in the scanner and it needed to be removed and smoothed back out to see what was underneath it. There are multiple curvature matching methods available to get it looking just right. Now, what if you need to modify the mesh? Like a design change. Let's say we're reverse engineering this part, but we need to change the size on the bore. No problem, just create a solid or surface body for the new geometry shape you want, and then you can trim the mesh back to that shape. Meaning just about any shape can be added or subtracted from a mesh or converted to a mesh as needed. Mesh models are also commonly used in 3D printing, but there you're usually just exporting geometry to a mesh file. You could already do that in Mastercam before, but now you can do it in the 3MF file format in addition to STL. So check out the entire mesh editing toolbar. It's really going to expand your ability to tackle those odd challenges that come your way.
Thank you, Marcus. Yeah, so this is a whole new toolbar. This is the first time Mastercam ever came out with it, so it's got some definitely cool tools in here. I'm not going to pull my best Bob Ross impersonation of brushing these little imperfections, so I'm going to show you a different tool in here. So maybe we have a very large STL and we want to just focus on certain areas. We have this option to explode it as well. Now, something that I like to do is I don't turn on the automatic preview, so it's not always trying to process it. I preview it myself, and now once I hit that preview, I'm going to see that it split that whole mesh into 38 different mesh bodies. Well, what are you going to do with that? Well, now I can focus my toolpath in that area. Maybe we needed to do a repair or something like that. We had to come back in. If you ever taken any of my Mill Advanced or Multiaxis classes, you know about using stock models to focus the toolpath. So now I can actually create a new stock model. We'll call it focus. No, if I remember how to spell. We'll use a model, and I'll select just this one pocket. And we'll build it up a little bit. And now we have a nice stock model to be able to say, hey, I just want you to finish rest roughing around these edges here. So definitely some cool options in there. And a whole new toolbar to get used to, so that's cool.
Hey, Jimmy.
Hey, Jason.
You going somewhere?
Yeah, I'm gonna be gone. I'll be working remotely for a couple of days.
You got your purple dongle with you?
Well, you know, I don't have to carry that anymore.
Why?
Well, didn't you know that right now with the software license, I can borrow a seat and take it with me anywhere I go?
Oh yeah, that's that network thing, right?
Yeah, absolutely.
All right, well, good riddance.
All right, man.
I mean, goodbye.
See you later. That's Jason, I swear.
So that's a pretty cool option. Did you know you guys can borrow a license? So maybe you're trying to go to the lake and you still need to work on your computer. You don't need any internet access. Just borrow a license and there you go. All right, next we're going to go over with holes in tooling with the help of my good friend Sherman.
Hi, my name is Sherman Snyder out of our Houston, Texas location. And today I want to talk to everyone about hole making in Mastercam 2022. Over the past several releases, Mastercam has made things faster and easier on the user end with options such as automatic depths, multi-axis positioning, and even a streamlined interface that we now see under our 2D section. In 2022, we're seeing major improvements with collision checking as well. Let's create a drill operation and see what Mastercam has to offer for collision checking with Mastercam 2022. For these holes, we will be using a spot drill, and we will make it a multi-axis toolpath since the holes are in different orientations. On the linking parameter page, we have a new check collisions button that now checks for collisions between the tool assembly and the part. Notice the top of the holes are okay, but a couple of the bottom holes immediately show that we have a problem. If I click the drill location, it shows a tool assembly at the hole location so I can see what's going on. Let's hide the holes that don't have any problems, and we'll see if we can fix the holes by adjusting the tool stick out. I can adjust it manually, but I don't want to stick it out any further than I need to. So I'm going to tell it to give me a 50 thousandths clearance, and then I'm going to click on the new Optimize Tool button. And just like that, all the collisions are resolved, and the tool is not sticking out any further than it needs to for this particular part. Let's generate this toolpath and see how close we are. And it's feeding through the middle of the part, well, because of course it is. Let's go back to the linking parameters page and enable the new automatic linking option. which is not only going to optimize the order it drills the holes in, but it's automatically going to enable a safety zone, which is going to eliminate the collisions as it indexes around the part. This part has already predefined safety zone, which you may recognize as the wrap feature from 2021. It makes it so easy to create a simple shape with an offset. And let's generate the toolpath now, and you can see it has no problem clearing the part. And it even optimizes the order of the operation on these holes to minimize the total feed distance. This toolpath is done, but I know I'm going to need to create a new tool assembly to mill out the deep pocket here. So let's take a look at a completely new tool manager that doesn't require a separate interface to use, and you don't have to create a tool using a mill license to define your tooling assemblies and your holders. The tool manager has its tabs now for assemblies, tools, holders, including filters to make finding the right component quick and easy. Let's create a new tool assembly so you can see how it works. I'll give it a name. We'll add a 1/2 inch ball nose end mill and select the holder I want. And we'll use this from the library. And just like that, I've got my assembly started. But I need more reach for my part with deep pockets, so I'm going to define an extension between the tool and the holder with a right click, add component above. Instead of grabbing this from the library, I can define it as a series of simple segments dimensioned, and when I click OK, it adds it to the assembly to make sure it will work. I can further refine this by editing any of the dimensions or modifying the component engagement length to create the exact tool I need. Let's build a custom library in this tool manager for the tools in our shop, and we'll add this assembly in there for reuse later on. I can also load up the extension of the holder as a reusable component as well, making it easy to get to the exact tools that I need and want to use at a later time.
Thank you, Big Sherm. Yeah, so that's pretty awesome. Gone are the days of selecting a tool and having to create a toolpath just to get to your assembly. Let's play around with that. So in my tool manager, I don't have any tools selected. I'm going to go ahead and create a tool assembly. I'm just going to leave a generic name for right now. Add a holder. I can go ahead and select one from my library. Oh, we'll go B4C4 and go with the ER20 style. We'll add a tool to it real quick. And I want to do spot drills, just do a 1/4 inch spot. So I'm probably going to shorten up that. I don't have too many spot drills that are that long on the flute length. Drop that to 1. Drop this to 1.5. And I can come over here, adjust my projection. So I haven't created a toolpath or anything yet. I'm doing all this already. So you can build up your whole tool library and everything you need before even creating any toolpaths. Cool. Let's make sure I got a machine in here, and let's just do a chamfer drill. I want to do a quick spot on my 136 holes and on my 089 holes. We'll select that fancy tool I just created. Set the cut parameters, give it a little bit of a negative number. That way I'm just spotting it. I'm not trying to chamfer it or anything. Right now we have 3 axes. I'm going to switch that over to 5 axis. Before I do that, that's going to be controlled by, I want to make sure I had all my axes right. It also is fully aware of the model, and that's how it's going to be able to do the avoidance. If you needed avoidance geometry like a clamp or a fixture or anything, you can add that in there as well. Linking parameters. So on this page, I can come in here and it automatically shows me where I'm gonna have a collision. If I wanted to toggle in between those positions, I can. So as Sherm said, I could manually adjust this, or I can just come over here. I want 50 thousandths clearance and do it for me automatically. Everything's gonna clear now. Cool. I'll say okay and have a little bit of a retract, but that's no big deal. At least I'll miss it. Maybe I want to shrink that up. I'll go to automatic linking. I'll drop this down maybe a 1/4 inch. I'll say okay. That nice auto regen feature is in there. So now we're going around. Nice way to prove it out without crashing my machine first and losing trust with my operators.
Hi, I'm Taylor with MLC CAD Systems here in Austin. Did you know that in Mastercam 2022, you can merge several parts from many locations using one merge operation by selecting the control key as you drag and drop files into the Mastercam graphics window?
So that's a pretty cool feature. I don't know if you try to make assemblies of fixtures and have to bring it all at once, or if you have a library of bolts, clamps, fixture plates, any other fixture needs. If they're all in one place, you can just bring them all, select them all individually, and merge them all at once. So that's definitely a pretty cool feature that's got added. Next up, we have George out of Dallas, and he's going to go over simulation enhancements.
Hello, my name is George Simmons. I'm with MLC CAD Systems, Dallas, Texas. I'll be showing you some enhancements to Mastercam 2022 simulation. If you need backplot, verify, or simulate 3 or 5 axis toolpaths, you'll notice those are going to be processed much faster in Mastercam 2022, thanks to some performance or improvements in the source code. Let's simulate this roughing toolpath because I'm worried about cut depth and if I'll need to do multiple passes, and immediately you'll see that there's a collision where either the depth is too low or I need to select a tool with longer flute. Now, inside a simulation, you can directly measure the simulated result. So for this part, I can confirm the cut width or measure the amount of additional flute that I'll need to add to the cut so I can make this cut without having to do multiple step downs or having to go back and do the math manually from the stock and the tool and the cutter dimensions and stuff. One more thing you'll see in simulation is this new report pane where you can view collisions, proximity alerts, and axis overruns all in the single dialog box. This report pane can be filtered by alert type, and you can now even modify the distance that will trigger a proximity alert, making it easy to quickly find potential issues so you can make a great program. One more thing I like to do is to make sure the tilt table rotates toward the front of the machine as much as possible so the user can see what's going on. Let's fix these two issues. First, we'll change the tool to one with a longer flute length so we can remove the material in 2 roughing passes. Then we'll select all of those tool paths and choose Edit Common Values to access the setting you may not be familiar with or have messed with before. It's located in the miscellaneous values for these 5-axis machines. Here, you can manually keep the secondary axis positive. So let's simulate this one more time and make sure we've eliminated tool collisions and that the table rotation keeps the part pointed toward the operator whenever possible.
Thank you, George. Also, a quick little tool tip in there, mass edits. Hopefully everybody knew about that trick. Alrighty, so we got our part here. Here's what I think is a pretty awesome feature of it. Is how many times have we gone in, tried to set up our fixture, just to go verify a toolpath. I'll make sure I want to do that. Contour, go into my simulator, let that think for a sec. And then as soon as you get it ready and you notice your fixture is somehow magically attached to the table with a blank space, maybe it was a magnet that we didn't see or something, I don't know. I call it a wish device, wish it would hold. So I come in here and I notice my fixture is just magically suspended in air. Now, instead of going back and forth, trying to figure out exactly how much I need to move it, underneath the simulation tab, distance, I can do a quick axis align measure. Find a point on the bottom of the fixture, on the top of the table. Not a whole lot of information there yet, but if I go to details, it's going to tell me that my Z is minus 33.175. Close that out, come back into my simulator options. Do minus 33.175, enter. Go back into simulator. And what we should see is that my fixture is nicely mounted to the table. A lot less chatter that way. And we're processing. There we go. So looking around, fixture's finally, and I didn't have to go back and forth and try to guesswork on it. Other nice feature, if I go ahead and run that verification, if you're not seeing it, if you go to the view and make sure that your report is showing, we have a report tab over here on the right. And if I look at my collisions, it lists all the collisions I'm having. If I select that collision, it's going to bring it back into our simulation in that position where it actually had the collision. And I can go know that I need to modify the heck out of my fixture or readjust my lead in, lead out.
Hi, my name's Shane Powell. I work with MLC CAD Systems in Austin, Texas. Did you know that in Mastercam 2022, sub-program support was extended to Mastercam mill-turn?
Pretty cool. Definitely save you some code space on your mill turn if you can do some sub-programs, right? Alrighty. Next up, we have the faceless man, Danny, out of Austin. He's going to go over Steadyrest Support and mill turn.
Hi, I'm Danny Ornelas. For Mastercam 2022, we added support for two types of Steadyrest. We added turret-mounted Steadyrest that allow users to define a Steadyrest in the GMD component library, and this will live with all your other standard components like your chucks and your tools. We also added standalone Steadyrest, and these are defined as part of the machine itself, and they are set up within the LMD, and they reside in the machine environment. They can be programmed just like any other toolpath, and synced within the sync manager and fully simulated, including collisions and full motion of all the arms and the pistons. Let's take a look at this new functionality by adding a turret-mounted Steadyrest. I'll open this GMD component library and merge the Steadyrest geometry into this project. To add it as a Steadyrest, simply right-click and add Steadyrest. We'll define each arm and piston individually, importing the name and the color of the model, defining the center of rotation based upon the pin bore, and then setting the rotation limits and speed. Next, we'll add the cylinder and set the rotation and the speed for it. Now we'll define the rest of the geometry as the body of the Steadyrest. The imported Steadyrest has some wireframe geometry to define the center point of the Steadyrest, and now the geometry is all defined. We'll add it to the turret in position number 2, and we'll disable position number 1 and 3 to avoid any interference. And just like that, the Steadyrest is available for you in your component library. Steadyrest can also be defined in a standalone way within your machine's LMD file. Now, going this route does require a licensed machine developer to add it to your machine environment. The process is essentially the same to add, but instead you add it to a linear axis of the machine rather than the turret. Assign the Steadyrest to a programming stream and define it whether it's removable, and you're ready to go.
Thank you, Danny. Yeah, so if you're running a mill turn machine and it supports a machine-mounted Steadyrest, we can add that for you. If you had a secondary turret, you can add that yourself. So let's give that a quick look, why would we want that? Go into my code expert. We have it synced up already. I'm going to go ahead and launch my mill turn simulator. And I looked out by having all the sheet metal off already. Go ahead and simulate that. So we're going to see that it puts the Steadyrest in position, machines, does transfer. Actually brings in the subsegmental, machine the rest. It'll do its transfer and then do the milling on the end of that part, all while making sure that our Steadyrest didn't collide with anything. So definitely a nice feature to get that in there.